Alright, so in this video, we're going to have an AI agent make a pull request against a repo on GitHub. So I'm going to show you how we can have an AI agent clone a repo with a task, solve the task in Python, branch out, push the code, and make a pull request. And I'm going to walk you through why I think this is an interesting workflow from an automation perspective. We're going to have a look at how we can have AI agents work with Git. Then we're going to set up a GitHub agent in LangGraph, and I'm going to show you how we can have that agent solve a specific task given to the agent, and then make a pull request with the solution to the task. All right, so let's start off by talking about how we would like to work with coding agents. Now, by now, I'm sure that most of you have used an LLM to write code. You may even have created an agent that was developed to solve a specific task with access to tools that could pull data from some API or maybe pull data from a SQL database. The workflow, though, is pretty much identical no matter how you are working with the LLM or the agent. You will prompt the LLM or the agent, you will get the response. In this case, you will get code back. You're going to try to execute the code, then you're going to reprompt, you're going to get some new code back, and this cycle is going to continue until you have code that you're happy with, that you can deploy, and that works the way you want it to work. And this is fine. This is better than it was before, but we want more than that. We want the AI agents to be able to substitute human developers. And in order to do that, we need to think about how we are actually working with human developers. So if we have a look at a typical workflow or simplified workflow between developers in a team, if we start off with the guy in the red shirt to the left, now imagine that he has written some code and he wants to merge that code into the main branch in the code base. What he's going to do is going to create a new branch, then he's going to push the code to GitHub, and he's going to make a pull request. That pull request is going to trigger a CI pipeline, and once the pipeline succeeds, this is going to trigger a message to the reviewers, and the reviewers are then going to have a look at the code and then put comments in the code base, which is going to go back to the main developer, and he's going to improve the code. And that's going to continue until the code is in a state where it can be merged into the main branch. And the important thing to note here is that the developers are not wasting each other's time. They're not pushing code that's not working, and the reviewers are only going to get notified when the build succeeds. And this is very different from the way that we are working with AI agents today. But there's no reason that we can't have a workflow with the AI agents that mimics this workflow. And we might even do something that's better, because we can actually replicate the AI agents. So we can set up teams of agents where one team is responsible for writing the code, you have another team responsible for testing the code, and the agents can make pull requests against the repo, and then we can get notified whenever there's a change or whenever the build succeeds. In this way, we will be able to delegate the tasks to the agents, and we will not waste as much time interacting with the AI agents. And that's the main motivation behind this video. Now, before we move on to setting up the AI agent and making the pull request, let's briefly discuss how we can have an AI agent interact with Git in Python. So we have two main libraries that allows us to have an AI agent do anything that revolves around Git. We have Git Python that handles local Git operations, and then we have PyGithub that is specifically used for interacting with GitHub's API. And Git Python allows you to make local Git operations, such as commits, you can branch, you can work with files, and the syntax is pretty simple, and we can use that to create tools for AI agents that allows us to basically do almost anything with Git. Then we have PyGithub, which is specifically for interacting with GitHub, if we want to push code to GitHub, for instance. And PyGithub is a wrapper around the GitHub API that allows us to create a tool for an agent so that an agent can make a pull request against a repo on GitHub. It can clone a repo on GitHub, and it can almost do anything you will need or you can think of through the API. Now let's have a look at how we can have an AI agent created in LangGraph make a pull request. Here I have a repo with some projects. I'm in the middle one here called agent.pr. I have two files. I have agent.py, where my LangGraph code is defined. Then I have a notebook from where I'm going to execute the agent code. And I'm going to import run agent from agent. I'm going to walk you through the agent code in a bit. And I'm going to set the GitHub token for my environment variables. Then I'm going to set the repo name, which is agent task. And that allows me to run the code. And if we just take a look at the repo agent task, I have a README file and I have a task folder. And the README file is just describing that this is a repository that contains the coding task for testing automated code generation and PR creation. The interesting thing here is in the task folder. That's where the task is defined. We're going to ask the agent to do an array product calculator. And the problem we're going to ask the agent to solve is just a simple problem. Create a function that takes a list of integers and returns a new list where each element at position I is the product of all original numbers except the one at position I. And then we're going to set up some requirements. We want the function name to be calculate products. The input should be a list of integers. The output should be a list of integers. And then we're going to ask it to handle empty list and single element list cases, handle lists with 0, and the file name should be arrayproducts.py. And then we're going to give some examples. I also included acceptance criteria. We want type hints in the functions, we want docstrings, and we need error handling. Now, we're going to feed this to the agent. The agent is going to clone the repo and read the instructions, and then it's going to solve the task, and it's going to branch out, push the code, and make a pull request. Right, before I run the agent code, I'll just quickly go through the LangGraph setup. So I have a code solution here, which is a pedantic model with a description and the code solution. Then I have a graph state that contains a status of the workflow, the task content, the repo directory, a generated code solution that can be either a solution or none, and then the number of iterations. The first function is a clone repository function that will use a combination of PyGithub and GitPython with a GitHub token to extract the repo, and it's going to clone the repo and return a local repo directory. Then we are going to read the task markdown file. We're going to initialize the state of the workflow. So we're going to get the local repo directory. We're going to extract the task content. And then we're going to initialize the state. Then we need to generate a code solution. This is pretty standard, like setting up a standard LangChain chain. We have a prompt using a chat prompt template, and then we have an LLM with structured output. We're going to create a chain out of that, and then we're going to invoke that chain with the task content. And again, we're going to return the graph state. Then we're going to test the solution like we did in the last video with exec. So when we have a generated code string with Python code, we can use exec to execute the code and see if it executes. And then we're going to create the pull request. So we're going to branch out and we're going to push the code to remote. And then we're going to create the actual pull request with PyGithub. So those are the functions that we need to create the nodes. Let's just have a look at the workflow. We're going to set up a state graph. We're going to add the generate node. We're going to add the test node. We're going to create the create pull request node. And then we're going to define the core workflow. The edge between start and generate, that's the first edge we need because generate is the first thing we need to do. Then we're going to need an edge between generate and test. And we're going to need an edge between create, PR, and end. And then we have the conditional edge that determines whether we should continue or not. And should continue is the function that determines this. So if it returns generate, we need to read generate. If it returns end, we need to end. And then we're going to compile the workflow. And everything is going to be wrapped up in the run agent function. Now let's try to run this and make the actual pull request. So I already ran the first block here. Just going to run my agent, see what we get. Generated code solution, attempt number 1. Right. So successfully created a PR with the solution. And there's a link here. So let's have a look at the PR. And if I head over to GitHub, to the agent task repo, you see we now have a pull request made by the agent. We have a look at the commit, add array products calculator with the code. And of course, we also have the local version of the agent task repo with the task folder and the markdown file and the array products solution. And this is how we can have agents work in a way that's similar to how developers work. Of course, we need to add to this. For instance, we need to add unit testing, but that's a topic for another video. Thanks for watching.